Fuel calculation. Ethanol is a fuel, and when you burn ethanol, it is exothermic reaction. Exothermic reaction means it releases energy. Ethanol combined with oxygen, when you burn, it gives carbon dioxide and water energy release. Student, now let's look on to the energy. 1367 kilojoules per mole. What does this mean? This means you look onto the picture. When you burn 1 mole of a fuel, when you burn 1 mole of a fuel substance, it will release 1367 kilojoules of heat energy. Repeat. If you burn 1 mole of a fuel substance, you will release 1367 kilojoules of heat energy. So, this is called the molar heat of combustion. Molar heat of combustion, measured by mole. So this unit, it is not 1 unit, but rather is a 2 unit. One measuring heat energy, another heat measuring fuel substance. In this example, heat energy is 1367 kilojoules. Fuel substance require 1 mole of fuel substance. Now let's go on to the compare petrol and ethanol. If you compare ethanol and petrol, ethanol filled with oxygen gives carbon dioxide and water. Energy release 1367 kilojoules per mole. Petrol also filled with oxygen also gives carbon dioxide and water. Energy release 5470 kilojoules per mole. So on these two enthalpy graphs, which ones give more energy? Then obvious enough must be petrol. How much it give more? Almost 3 times more. So you can say petrol is a lot better fuel than ethanol. But wait a second. Look at this calculation have a 40. Why? The calculation is not 40, but the way it look 40. That's all. Why? Let's see. If you compare, what is ethanol? Ethanol is a 2C hydrocarbon. What is petrol? Petrol is a 8 to 12C hydrocarbon. And now you're comparing 2 things. You almost to compare the top one, a chicken, and the bottom one like a pig. And you ask, a chicken expensive or a pig expensive? Then of course by the size, a pig will be more expensive than a chicken. Then this way of comparison, you can say that's unfair. And then how about I measure it by weight? Would it be a different result? If I measure it by weight, I'll say, how about I measure by 1 gram of chicken and 1 gram of pork meat. Which one's more expensive? The result may be different. So here, that is the compare. Mole and gram. Look onto the gram. Ethanol, 29.7 kilojoules per gram. Petrol, 47.9 kilojoules per gram. The result, and now which ones win? Still petrol win. But does it win by that big 3 times margin? No, it wins, but it's not by that much. So student, you realize kilojoules per mole and kilojoules per gram will be different result. And now we're going to learn more. C2H5OH, it releases 1367 kilojoules per mole, and I want to convert it into per gram unit. How am I going to do it? Now let's draw the box. I have two parts in this box. One part is for the fuel, how much fuel substance. The other part, heat energies in terms kilojoules. So here you say, if I burn 1 mole of a fuel substance, it will release 1367 kilojoules. 1 gram of fuel substance, how much kilojoules? Number 1, use the molar mass to convert the mole to gram. What you need? You need to know the molecular formula, C2H5OH on the top, so that pull up the periodic table and add it up so that you can convert the mole, convert it into gram unit. When you add up, give you 46 gram. Rule number 2, cross multiply, divide the top. What do I mean by that? 1 times 1367 and divide 46 as follows. And here's the answer. What if I want to convert the kilojoules per gram into kilojoules per mole? First, find out the molar mass by using the periodic table. So you must know the molecular formula. If you don't know the molecular formula, you cannot do it. So know the molecular formula, pull out the periodic table, work out the molar mass. 46 gram. Now they are in the same unit. They're in the same unit, gram and kilojoules. Next step, cross multiply, divide the top. So it becomes 46 times 29.7 divide 1. And here's the answer.